Hello, welcome to another exciting series. In today's series, we would be solving a practical change of subject question in mathematics, right? So let's quickly delve into the series. So we have our question for the day to be: make D the subject of the relation, right? So our given equation is A equals 2B multiplying the root square of the fraction C multiplying 1 plus the fraction E square over D square, all in bracket over F, right? So our given equation based on the preamble is A equals 2B multiplying the root square of the fraction C multiplying 1 plus the fraction E square over D square, or in brackets over F, right? So here what you have to do first is to eliminate eliminate the root square of the equation, okay, by squaring both sides of the equation, right? So whenever you meet a practical change of subject question in mathematics and there's a root square involved, right? What you have to first do is to eliminate the root square by squaring each side of the equation. And based on our given equation, we have three sets of or three sides of the equation, which is A, 2B, and the root square of the fraction C multiplying 1 plus the fraction E square over D, all in bracket over F, right? So we have three sets of or three sides of the equation, right? So we square each side, right, of the equation. So we are going to have our new equation to be A square equals 2B square multiplying the root square of the fraction C multiplying 1 plus the fraction E square over D square, right? Or in bracket square over F, right? So we do some cancellations out. So this 2 will cancel itself out. So the purpose of the cancellation is to eliminate the root square, cancel itself out, to cancel the root square out, leaving the equation to stand on its own, right? This 2 would multiply to here, right? 2b square. So this 2 will multiply to here, okay, for us to get 4, okay. It will also multiply b, right? B for us to also multiply b for us to get b square, right? For us to get b square. So yeah, for this side of the equation, we are going to get 4b square, right? And a, a square like would give itself a square, right? So we are going to have a square to be equal to 4b square multiplying the fraction c multiplying 1 plus the fraction e square over d square over f, right? So we simplify, right? So this one here, every number has an invisible one, okay? So this one has an invisible one. So when you are solving or you are simplifying, you solve for the one in bracket first, right? So here you cross multiply, and you cross multiply by multiplying the denominator, okay, on your right side with the numerator on your left side. So d square would multiply 1, okay, multiply 1, okay. Then you also multiply the denominator on your left side with the numerator on your right side, which is e square, okay. So e square would multiply 1 here, okay. And when you are done, you multiply, okay, both denominators. So 1 multiplying d square, right, which is d square, okay. So that's how the cross multiplication is done for this kind of fractions, right? So we are going to have our breakdown to be a square equals to 4b square multiplying the fraction c multiplying 1 over 1 plus e square plus the fraction e square over d square, right? Because of how I explained it, right? So we are going to have a square is equal to 4b square multiplying the fraction c multiplying the fraction d square plus e square over d square over f, right? So d square because, right, d, the denominator d square multiplying the numerator 1 will give you d square, okay. The denominator 1 multiplying the numerator e square will give you e square, right? And the two denominators multiplying each self will give you d square, okay. So that explains why we had this fraction, okay. So simplifying further, okay, we are going to have our a square equals 4b square multiplying the fraction c multiplying d square plus e square over d square, right, all over f, right? So as I explained earlier on, every number is divisible by 1, so it has an invisible one. C has an invisible one here, so it's multiplying the entire fraction here gives us c over 1 multiplying d square plus e square over d square, right? So when you are doing multiplication for fractions, okay, the numerators will multiply the numerators, the denominators will multiply the denominators. So we are going to have c multiplying d square plus e square and 1 multiplying d square, okay. So we are going to have our a square equals to 4b square equals cd square plus ce square over d square over f, right? Because c multiplying d square will give you cd square, c multiplying e square will give you ce square, and 1 multiplying d square will give you just the number d square, right? So in simplifying further, Okay, based on our equation, we have a square equals 4b square, multiplying the fraction c d square plus ce square divided by d square divided by f, right? So we simplify. So a square equals 4b square, multiplying the fraction cd square plus ce square over d square divided by f over 1. So this f, like I explained earlier on, has an invisible one because every number is divisible by 1. So that explains why we have f over 1, right? And when you come here, right, what you have to do here is we have a division sign here, okay? So when dividing a number by a fraction, okay, you actually perform multiplication because dividing by a fraction is equivalent to multiplying by its reciprocal, okay? So dividing by a fraction is equivalent to its reciprocal because of the fundamental properties of division and multiplication. So that means that for this division sign, we have to eliminate it by multiplying, and when we multiply the fraction here, f over 1 will change its form, okay? F over 1 will change its form inversely, right? Inversely. So it will change its form inversely from f over 1 to become 1 over f. So we have our new equation to be, right? So as I explained earlier on, right? Inversely, right? Okay. So so have a clear look at it. So we have a square equals b square, multiplying the fraction cd square plus ce square over d square times 1 over f, right? So here the mathematical sign have changed to become multiplication, right? And immediately you change the division sign to become multiplication, you inversely change the fraction, right? Inversely. So if it's f over 1 here, right, inversely changing it becomes 1 over f. So it turns upside down, okay? In a layman's voice, it will turn upside down, right? So that's what it means. So you have to take clear notice of that. Now now let's proceed further. So now we do our multiplication. So I said earlier on that when you are doing multiplication with fraction, the numerators will multiply the numerators and the denominators will multiply the denominators, right? So cd square plus ce square multiplying 1, right? 1 times cd square plus ce square will give you that same cd square plus ce square, which is here, right? And d square multiply f will give you d square f, right? So we have our new equation to be a square equals 4b square multiplying the fraction cd square plus ce square over d square f, right? So now we have our a to be an a square. So our a is not independent, so it's not standing on its own, right? So we have to convert it for it to stand on its own, right? So, and also we have to deal with 4b square, okay, multiplying the fraction cd square plus ce square over d square f, right? So in doing so, 4b square is multiplying this one, so it's multiplying this fraction. So this fraction 4b squared, right, has an invisible one because every number or every variable is divisible by 1, right? And a squared, this 1 squared too, is divisible by 1 here, right? So in multiplying, you are going to have a squared to be the fraction b squared over 1 multiplying cd squared plus ce squared, right? So in I explained earlier on that in doing multiplication with fractions, right, the numerator, which is the top values, right, the top values here, okay, so this is the numerator, the top values here, right, numerators, right, and the down values are the denominators, right, so the down values are the denominators, right? So the numerators would vertically multiply themselves, right, and the denominators will vertically multiply themselves, right? So 4b squared multiplying cd squared plus ce squared will give us, okay, will give us 4b squared cd squared plus 4b squared ce squared, right? 1 multiplying d squared f will give us d squared f, right? So we are going to have our a to be the fraction 4b squared cd squared plus 4b squared ce squared over d squared f, right? And still our a is not independent, or it's not standing on its own for it to become the subject of the relation. So what we have to do is to take some action on a for a to become independent and stand on its own, hence becoming the subject of the relation, right? So as I explained earlier on, when it comes to square and square roots, okay, if it is a square root or root square, in order to eliminate it, you square the root square, right? But when it comes to square roots, right, a number having a square root, if in similar trajectory, right, if you want to eliminate it, you also bring on board a root square, right? And whatever you do for the left hand side, do same for the right hand side. So that means we have to introduce a root square into the equation here for us to eliminate the square here, right? So we introduce a root square, but before that, right, before that, a square, as I indicated earlier on, has an invisible one, right? Okay. And when you have two different equations within a setup, right, you do your cross multiplication. And here you don't, when you cross multiply, you cross multiply the denominators and the numerators together, right? But afterwards you don't multiply the two denominators as we do for fractions that are together, like the one we did to like the one we did earlier on, right? So these are fractions in different half of the equation, right? So here you multiply through with the denominator on your right hand side with the numerator on your left hand side, and the denominator on your left hand side with the numerator on your right hand side. So we are going to have a square multiplying d square f, right? And also we are going to have 1 multiplying 4b square cd square plus 4b square ce square, right? Or in similar fifth, you can also multiply through by the LCM, which is d square f. Okay, so the LCM is d square f because 1 multiplying d square f will give you 1. That means d square f can enter 1. It can 1 also can enter d square f, right? So making d square f the the LCM of the equation. So these are the two ways you can do it, right? So cross multiplication or multiplying through by the LCM, right? So the first is cross multiplication or multiplying through by the LCM, and similar ways you can arrive at your answer. Okay, so we are going to have our new equation to be a square multiplying d square f equals the fraction 4b square 4b square cd square plus 4b square ce square over d square f multiplying d square f, right? So d square f would cancel itself. D square f would also cancel itself. So we are going to have a square multiplying d square f, right? So a square multiplying d square will give you a square d square, right? D square f, right? A square multiplying d square f will give you a square d square f, right? And through our cancellations, we have the other side of the equation to be 4b square cd square plus 4b square ce square, right? So so simplifying further, right? We have a square d square f minus 4b square cd square equals 4b square ce square, right? So we want d square rather, yes, this d square rather that we want it to become the subject of the relations, right? So we have to group like terms. So sorry about that. It's not a square, it's d square that we want. It's d that we want it to become the subject of the relation. So with regards to that, okay, we have to group like terms, right? So those with the common factor d will be on one side, and those without d will be on the other half, right? So a square d square f equals 4b square cd square plus 4b square ce square, right? So we would maintain a square d square f, okay, and we would bring on board 4b square cd square, right, because it has a d component in it, and this 4b square, this 4b square cd square, okay, it's a positive number. So when it crosses the equal to sign, it will change its form to become a negative number, because whenever a number crosses the equal to sign, it changes its form to become a different form of a variable or a number, right? So it will change to become a negative variable or number, right? And we would maintain 4b square ce square because it is an unlike term, and it doesn't have a d component in it, right? So we have a square d square f minus 4b square cd square equals 4b square ce square, right? So we factor out d square, right? So we bring d square out. So which number can multiply d square for us to get a squared d squared f, and the number is a squared f, right? Which number can multiply negative 4b squared cd squared for us to get negative 4b squared cd squared, and that number is 4b squared c, right? So we have d to be multiplying a squared f minus 4b squared c, which is equal to 4b squared ce squared, right? So we want to make d the subject of the relation, but we have d squared, right? So we cancel out the dependent variable surrounding d squared, which is a squared f minus 4b squared c. And when you are doing the cancellation in mathematics, whatever you do for the left hand side, you do same for the right hand side. So we have d squared equals a squared f minus 4b squared c, right? Dividing through by both sides of the equation. So we have our new equation to be the fraction d squared multiplying a squared f minus 4b squared c, right, over a squared f minus 4b squared c equals to 4b squared ce squared. That's the fraction 4b squared ce squared over a squared f minus 4b c, right? So when we cancel out, right, a squared f minus 4bc, 4b2c will cancel itself. It will cancel a squared f minus 4b squared c. Okay, for us to get our new equation to be d squared equals to the fraction 4b squared ce squared over a squared f minus 4b squared c, right? So d squared here cannot be the subject of the relation because d is not independent, right? It's dependent on the square here. So we have to eliminate it, right? So in eliminating it, as I explained earlier on, you introduce the root square, right? So if it's a square and you want to eliminate it, you introduce the root square. If it's a root square and you want to eliminate it, you introduce the square, right? So we introduce the square, right? We introduce the root square, right? So these two will cancel itself. It will cancel the root square for d to be on its own, right? So we will have our final answer to be d equals the root square of the fraction 4b squared ce squared over a squared f minus 4b squared c, right? So this is our final answer. Thank you so much for watching today's video. Kindly do well to subscribe for more. Thank you. Bye.